Good evening. So my project is about the kinematic evolution of the Willard thrust sheet in the Sevier fold and thrust belt in northeast Utah and southwest Wyoming. Means nothing to you guys, but I'm going to explain it all. Basically, I'm studying the structural change that occurred in the Earth's crust in North America around the time of the dinosaurs, or about 130 million years ago. This change actually created a major mountain belt that stretched over 4,000 kilometers from Canada all the way up there down to Mexico. And that was called the Sevier mountain belt, or the Sevier orogenic belt, or the Sevier fold and thrust belt. That belt is the result of plate tectonic subduction off the west coast that forced the oceanic plate beneath the continental plate and shoved the upper crust over 200 kilometers eastward. The Sevier orogenic belt is actually one of the most studied mountain belts in the world because of its awesome location and because of its potential resource extraction. Almost every stage of the mountain building process is preserved in the sediment adjacent to that mountain belt. However, the initial timing and the early deformation history are poorly understood, which makes all that previous work incomplete. My study area focuses in Wyoming, Utah, and Idaho, right there. And basically, I'm going to study the sediment that was shed off of that mountain belt into a basin that was adjacent. So that's where my study area is. There's a unique dating technique that's been developed in this field of study that uses a unique mineral called zircon. It's a small grain that is ejected from volcanoes and then almost immediately deposited in sediment. Using those grains, I can obtain radiometric dates that represent the depositional age of each unit within that basin. The sediment that's related to the deformation also is expected to show something called an unroofing sequence. It's basically where the youngest, most top layer of the mountain is shed into the basin, and then it's followed by the previous layers. That way you can date the sequence. By combining that unroofing sequence of the sediment in the basin with the radiometric dates of the zircon grains, I can constrain the initial timing as well as explain in detail the early deformation history of that belt. So as I said before, the Sevier orogenic belt, or the mountain belt, is one of the most studied belts in the world. With data from my study combined with that previous data, we can create better models to predict where resources are, such as oil and water. Additionally, we can use those data to create crustal models, which can be used to predict earthquake prediction areas. So overall, the sediment in the belt related to the belt provides a unique exhumation history. Thank you.